All right, so we're going to go over that problem towards the end of chapter 9. And one thing I wanted to look at first was how in the world did we read information from our file? And I did a little searching back in the book and under File I/O, and I found an example way back in chapter 3 where they have this little line right here. To read from a file, here's an easy way to create a scanner variable called inFile. This is a nice way for reading data in. Since we've been using scanner quite a bit in the just reading from the console, it makes sense to use the scanner unless we see some other feature that we need in order to read that data. So here's a nice way to read data just from their example. I don't need to know much more except how to read a line. Right now they did a inFile.next, but there's also inFile.nextLine. Lets me read a whole line from a file. And the point for that is, back here in my project that we want to run is, I want to read data from a test file. And last time we looked at actually generating this array by hand. Like we could have done this before I actually had test data read working. I can just say, okay, I don't know how this is going to work here. I know I want to do it this way in the future, but suppose I already have that working. I'm going to have some test array like this, string array. I'll call it a test data right now, and equals, and then I can just say this is an array of strings. Here's the answer key. Here's my first student, and here's their answers. They did 100%. Here's my second student. Nope. And their answers were half right, or 1/3 right. And that can be my test data. And then I can run my testGrader program on that, based on that data. And let's do that just to see that my testGrader is working. I'll walk through my code for testGrader. And what I did, I actually, after the last class where we kind of built this, I built it again just for fun, completely from scratch, not even looking at my previous code, just so I had a good handle on maybe thinking through it a different way. That's something I learned from when you want to developing your skill in programming, similar to drawing. I enjoy doodling little cartoons here and there. And I listened to a guy once talking about developing your drawing skills, and one of his statements was, always just throw away your old drawings. You're not working at making and selling art. You're working at learning drawing. So you don't go back to an old drawing and start building it again. As you want to practice your drawing skills, you start with a blank sheet and practice drawing that picture again. I think of that when I'm doing my coding. As I get more complex programs, I might go back and look at the old program, how I did it. But I avoid the copy-pasting my other work, especially when I'm trying to develop building it from scratch. So you'll see how I built it from scratch again, and see if I think it's a little more efficient than the last time we did it. So let's just run this and see what happens first. Oh, and here's the results. Let's run it again here. I had 3 students that when I read it from the file. Let's run it now. Where's my run? There it is. Run it now. Oh, I had an error. What happened here? Oh, array out of bounds. Oh, I messed up. So my code right now that was ready to read from a file, I got a problem there. I think, let's try this. I think it goes until it sees a no. There we go. So I'll have to fix that later. So there's my code working just with that test data. So let's take a look at what that code is, just this part here, and then we'll come back to the reading from a file. And I think, did you both guys get that part? If you had an array, you could process it? Tried? Okay. Well, let's see how I did, and then we'll come and take a look at your code. And you can look at mine while you're. Do you have your code online at all? Okay. Well, you can copy mine and see how it compares how you thought through it, because it's not super long. So I'll jump down to the part where I'm taking a string of an array of strings, and here's my answer. Where first of all, just to make my code a little easier to read, I store a test data 0, since I know that's my answer key. I could have just always referred to this, but that gets a little awkward as I'm reading through the code. So I'm storing that in a variable called answer key. And what I decided to do is, rather than print the results while I'm looping through here, I decided I'm going to return a string that will show all those results. And this is one thing that a lot of programmers will do, and as you build your more complex code, what I'm doing here is, rather than worrying about where the output goes, I'm just building a string, and then the calling part of the program can decide what to do with the output, like print line. If it were graphically based, I would get my grade results and then go put it in some text field somewhere else. So this prepares me to think, don't have this function testGrader worry about where the output goes. Just have this testGrader create the string, and then the calling program decides what to do with that output. And in this case, the calling program says, oh, okay, print to the console. But as we do more sophisticated GUIs, we decide to put that string either to a file or to a text box somewhere on my graphical interface. So that's what this is about. I'm building a string as I read through the test data and calculate the scores. All right, so I'm going to put comments here too, because as I was doing this, I wasn't commenting. So I'll add comments as I go. And if you ever do that, the code's in your mind, you write the code out. Go back then and think, okay, I'm explaining this to someone. Let's add comments after I've gone through it. So here's my loop. I'll just put here loop through the test data from students. And I'll put a little comment here. Element I is student ID, and element I plus 1 is the student's answer. Oops. In a string. Okay, so I set to be 1 because position 0 was the answer key. Now here's the part where when I read it from a file, what I did is I created test data of 150 strings, and as I read, it was filled with 0 by default, and as I read from the file, that data got filled with information. So here's the ending condition when I have data that I read from a file, that it'll hit a null when the data is over. And in my test data I created by hand, here's why I was getting an error, because I didn't have a null in there. It never knew when to quit. So back to here, as that data is not equal to null, each time through the loop, I start my score at 0. And I'm going to put a little white space in here to make the code a little more readable. And I'll put in here start with score of 0. And now I'm calculating my score as I compare one by one their answer. So I'll put that in the loop here, or put in my comment for this loop. Check student answer letter at a time. Character, I'll call it one char at a time. All right. And to get at each character now, I have a new looping variable j that starts at 0 and goes to less than the length of my answer key. And again, to make this a little more readable, I like to put spaces. It's your choice. So as I read that answer key, one letter at a time, J is going to be taking the value of 0 to 1 less than the length of the answer key. Now notice this is assuming that they've given me that many letters in their answer. So we're not doing error checking right now. Maybe I'll put a little comment here. To do, add some error checking. In case they haven't given me all the answers. I'm assuming there's either spaces or letters equal to all their answers. So if they haven't given me any answers, the system should have given me three spaces in their answer. Okay, so now here's my loop where I simply check. First thing is, did they get the correct answer? And if it is, I can compare characters. The character at position J, is it equal to my answer key, or sorry, is the answer key at position J equal to their answers at this location here? A test data I plus 1. Hey! Going through the my solution to that last problem. Now, what I'm going to do here, just to make this code a little more readable, I'm thinking that this might be confusing, and if I come back later to read this, what I might do is something like this. As I go through the data, I'm going to do this just to make it a little more readable. I'm going to say string. I'll call it, we have the answer key. I'll just call it answers equals a test data I plus 1. Now this doesn't change the logic, it just makes it a little more readable. And instead of referring to a test data I plus 1, I'll just put answers. It's the exact same data, but it might make it a little more understandable that I'm comparing the answer key at position J to their answers at position J. So this is only to make my code more readable for the variable name. So if they've got the correct answer at J, I give them 2 points. And then not anything other than a space receives -1. So I don't have to do a score plus equals 0 or anything. I just ignore it. If it's a space, they haven't got the right one, and it's not a space, I subtract 1 from their score. And I don't notice here, this is where I compare it to, if they've given me a space, they get 0 points. Now the one problem with this particular approach, if someone decided that, oh, if they don't answer, they do get a penalty, I'd have to change my code to handle what effect on the score is if it is a space. So I'd have another else if. But right now, the logic they said is they get a 2 for the correct answer, 0 penalty for no answer, which is a space, and there really should be, if one is true and the other is false. I'm not limiting it to anything. All I'm saying is whatever letter they give me, if it's in the answer key and they have put that letter in, they get a 2. So I'm not even caring whether it's true or false. It's, does it equal the answer key? So if I wanted to do some error checking, I might check, did they only write true or false and not some crazy letter? But right now it is if they've given me the same answer as what's in the answer key, they get +2. And anything else, anything other than a space, they get penalized for. And that's it for figuring out their score. And the rest is basically one line to show their results. I did this all on one line. I could have used temporary variables, and I'm just going to add some carriage returns here just so it's readable code. So you can see all my calculations. I'll put them kind of logically. I put their percentage in parentheses just for fun, so it comes out something like this. And maybe I'm going to put a space after the score. Don't like them packed in together so close. And then this here is increment to next student. So this is all the code that gives me the processing once the data is in an array of strings. And Kishan, I'm recording this, so you always be able to go back to the start. Yeah, I'll put it on my YouTube page. Yep. Okay, so let's go through this then, just reviewing with the added comments. My test data at position 0 is my answer key. Store that in a nicely named variable. My result, I'm going to be building a string. I'll put a comment here. Build a string to return. So this function, as I calculate the scores, I'm building the string here. Notice here I'm doing an sResult plus equals. I'm not doing a system.out.println. Letting my calling program decide what to do with the output. So rather than show the results, I'll call that build the result string. Add to the results string to be returned. So let's walk through this little line here. I have a string. It's going to represent their student ID, or it's just saying what comes next is their student ID. Concatenating using the plus symbol. And you know what? I like a space. I'm going to add a space after that. Don't pack them together so close. Here's their data, their test data. That's their answers. And you know what? No, this is the student ID. The test data I is their student ID. And because I had changed that variable to answers up above, or held it there, I'm going to make it clear here. I'm going to put that's their answers that they gave me. Then another string saying here's what their score is, concatenated with the score, the raw score. And I decided to calculate their percentage in this manner. And this is a tricky thing to think about. I did 100.0 to make sure that Java is using doubles in this calculation. If I only did 100 times score, it's going to be doing integer arithmetic, and it's not going to give me decimals in the calculation. So this is a trick to tell Java, by the way, at this point here, treat everything as doubles. A nice way to give you, if you had decimals in your answer, forcing it to do all its math with doubles. I could have tried casting it to a double after all the calculations, but I will still lose the decimals because it's doing its math with integers unless there's a double somewhere in the calculation. That's a nice little trick to remember in case you ever want to think, in case your math is coming out wrong, say, oh, let's make sure he's doing math here. I could do this here as well. 2.0 tells Java, oh, treat that as double mathematics. But if there's a double anywhere here, from then on it will calculate using a floating point. And now, oops, now to the right there, all I have to the right of this line is the added parenthesis and this \n for making sure it appears on a new line. So this was the processing, assuming I had gotten my data into a string array. Any questions about this? Okay, so this is the easier part. The reading from the file is actually a little trickier. Here it's just a matter of, oh, I'm comparing letter by letter. If they've given me a space, they don't have any penalty. Anything other than a space, they lose a point. And remember, it's important that before I start this loop, I'm always setting my score variable back to 0 every time I go through a new student. So I have this array that looks like this. That's element 0. We'll just do a little comment above this here. There's element 0. This is element 1, element 2, element 3. So every odd numbered element in there is the student ID, and the one coming after it, the I+1, that's the answers they gave me. So feel free to do this in your comments as you work through code. Anytime anyone's reading through that, you'll see, oh yeah, those are the indices. And to know I'm done, I look for a null value in the next value in that test data string. All right, now let's see how we actually read from the file. Here I commented out so I could manually create some test data just for fun. Now I'm going to read the data from this text data file. Let's take a look at that file to make sure it's in the right format here. And I come over here to my project, go down into my source. Or actually, it's not even in my source. It's right at the project level. I created this data file. So what you can do to create that file, you can just right-click on your project, do New, File, and it'll create a text file. And when you save it, it'll give it the file name. So let's just show you by example. I can do New File. I'm going to give it a file name. I'll call it example text file. And you decide what suffix to give it to. I'd like to give it .txt if it's an ASCII text file. And that file will appear in your project, and you can edit it just like any source file. Put data in there. And then Control S, it will save that file. And here's my test data format. Here's the answer key. Here's the student IDs I'm giving them. I'm going to change those, make them nice long IDs like they have. Doesn't matter. What determines the end of my student ID is there's a space between it and their answers. And again, just to add a little interest here, I'm going to put they missed the answer on one of them. And I just realized that's not going to work if there is. No, let's see if we'll put a space here. I'm going to put a space in the middle, and then later I'll come back to see if a space at the beginning or ending also works. So there's one that missed an answer. So there's my test data stored in a text file. So what I'm going to need to do, I'm going to need to read the first line. And that's going to go into my answer key. I'm going to read the second line, and I need to find the student ID based on the numbers before that first space. And then the rest of the line is going to be their answers. So that's actually the trickiest part here. How do I split this line up into getting their student ID that comes before the first space, and then putting their answers, that's the rest of the line. So here's how I did it. It's not the only way to do it. So let's go back now and see how I did that reading of that data file. So you see how the format of that data file is critical to be clear exactly how that's formatted. Notice I'm assuming, I'm not doing any error check, I'm assuming they gave me the same number of letters here that is in the answer key. Let's go back now to my main class and see how I process that file. This is my second version, I did another one where I went character by character, and I came across a nice little function I think it's worth knowing about. So here is my solution. I decided to create a string ready to hold 150 answers. And I'm realizing that I need to make that 151 because the first thing in the string is going to be the answer key. So I'm going to put in here answer key plus 150 students. Uh-oh. I just realized if I have 150 students, they're giving me both the student ID and the answer. I better make this 301, not 151. Because there's two strings for each student, their ID and their answers. So I wasn't making enough room. And fortunately, my test data set didn't have 150 students, or I would have had an error. Now here's the key to actually getting that file started. Notice here in the parameters to this program, to this function, way up here, I've decided I'm telling it what file to read from in the call to that function. So I'm going to comment that out. I'll comment this out now. I'm going to use now the real, let's read the data from, here's your file name. In case I ever again decide to use a different file, I have that name encoded in the caller. So the function takes that file name right there, and I'm giving a variable named s file name f as s as it, because it's a string, f name for the file name. I'm starting to build I make room for this many strings in my string array. And now we come to the part where if I want to read from a file, you have to put any file IO inside of a try catch. Have you seen the try catch before? Okay. Here's how I did it. I knew that I wanted to do a file IO, so I said, let's make this scanner, and let's say I call it a T file, equals a new scanner, and then that scanner is a file reader, just like that example in chapter 3. And I'll take test file. When I do this, this is where Eclipse helps me out. Eclipse says, or shows that there's a problem here. It says there's a problem whenever I try to do file IO. And in order to do this, I also make sure I have an import of java.io. And actually, I don't need to do all these one at a time. I saw in chapter 3, if I want to do the scanner, I have to import java.util.scanner. I could have done here, import java.io.star. Have you seen that before? If I know I'm doing IO and I don't care which specific IO functions I want to use, if I do import java.io.star, that makes sure they're all available to me. Usually I'll see people doing that, and unless Eclipse has done it for me, I'll say, oh yeah, I need to do some IO. I'll add that import at the beginning. These were added by Eclipse because back down here, when Eclipse sees there's a problem, all you have to do is hover over that red squiggly, and it'll say, here's your problem. Since file IO may cause an exception, you need to put it in a exception catcher structure, and I can go down here and do it for me. Surround it with a try catch. And here's what happens. If there's a possibility of this producing a file IO error, here's the exception handler that needs to be in there for it to be properly handled. So I did that when I was writing this. Eclipse put in the try catch for me. But after I do this for a while, I realize, oh, I need a try catch. I will often write it there myself. And instead of file not found exception, I can put exception not knowing exactly what kind of exception, I can just put exception there. See, what if anything goes wrong, I can read the get message from exception and find out what the problem was. So I don't have to name each specific exception if I do this by hand. So that's what needs to happen around any attempt at file I/O, or Eclipse will complain about it, and it won't be a nice, tight code that catches errors. Okay, so seeing that, I let Eclipse do that for me. And now, if I read the file, notice I'm not doing any error checking. The exception catcher will do the error checking, essentially, if there's a problem reading that file. Now, here's the part where I read my first line. Here's the code to read one line of text from a file, if that file is a scanner. So a nice, concise, I don't have to read one character at a time until I find the /R or /N. It's just, give me the next line. Nice, clean way to get a line from the file. And again, I'm assuming the first line I read is my answer key. And then I'm keeping track of what line I'm on now, because that's this is student, or this will be student number 1. And I'm going to be putting that information in my result at that position I. So that's why I start with 1. I'll say storing results, storing data into a result I as I go. So in order to get the student ID, here's the little trick. I read a line, and I use this wonderful little function that strings have built into them, this little function called split. Have you ever used the split function? It's a really nice thing. Rather than me hunting for the first space, I can just tell it, split this string, wherever you see the string I give you here, use that as the divider to split it into an array. And since it's an array, and all I care about is the first element of that array, I can take the array it gives me and just get element 0. That gives me my first word of the line. Does that make sense? The split is doing all the work for me. I could have written a little loop that said, while char_at is not equal to space, build a string of all those chars as I go looking for the space. But I found this split function just basically based on the autocomplete that I was seeing when I thought, I think there's something I could do with the string to get at that first word. Split it. This turns it into an array, this part here. And because it's an array, I don't need to store it in a variable. I can just say, oh, since you gave me an array, this says give me the first element of the array that split returns. Don't need to store it in a variable, just because I'm not doing anything else with it except getting the first part of it. So this little thing right here is a nice little construct, assuming that the space is what determines where that first word ends. This is great for handling a line of CSV data. Reading from an Excel file, I put a comma there, and that would give me an array of all the elements in a CSV file, one line at a time. So it can use this. There's so many places that this can be used. You see why they built this split function. It's a standard part of strings, methods available to the string object. And now to get the rest of the line, here's what happens with that. What I need to do is I need the rest of the line starting where this one ended. Well, to know where this one ended is, well, how long is this result? That's right here. The length of that result is, and I'll give you this all in one page here. Here's the starting point for reading the rest of the line is how long that substring was plus 1, skipping the space after it. So the length of what I just got here, a result I, plus 1 is where I start reading, and then give me the ending index. That's where the substring function is another great method of strings. Give me the piece of the string starting here and ending here is essentially what substring does. And if you hover over that, I think it will show you the definition of substring. Another great feature of Eclipse, where there's great online Java compilers, but I think NetBeans does this as well. Hover over this, get a nice help, and I can page through here and just read, and sometimes they even give examples. This one didn't. Well, yeah, here's an example. So great help with that. This gives me the rest of the line that I put into a result I plus 1. So now that's the answers for student I is an A result I plus 1. And now, because I want to go fill in if there's something there, I want to fill in for the next student, I increment my I indexing variable by 2, and now check to see whether there is a line. And again, here is that scanner has next line is a way to tell whether there is data there ready to be read. So a pretty slick technique to read a line into variable S line, get the first part of it ending at the space using the split method, and then element 0 of the split method gives me the first word in that line. This gives me the rest of the line, and I'm going to put a little comment for that. Get the rest of the line after first space. And if I think about this, suppose they did not answer the first question, there would be 2 spaces after their student ID. And the way this looks like, I'm only going 1 after I found that first space, because the length of that first word would end at the space. And so this then will catch anything, even other spaces, in that A result I variable, or the S line. The S line has the whole line. I go to the end of it, and then I simply put that in my array. And when I'm done, this is always a thing to do. Whenever you're dealing with files, be sure to be a good citizen with Java and close the file. Java will close files at the end of the program, but it's best to close them. Make it a good habit when you're done processing any file. Close it when you're done with it. Otherwise, it's hanging around, left open. You've lost your reference to it as soon as you've left this function. Java will eventually do a little garbage collecting and close it, but it's best to close it when you know you're done with it. So I'll put a little comment here. Close my input file. Now, to debug this, let's just go ahead and put a debug breakpoint right here before I return from this. And let's run this in debug mode. And you know what? I'm going to stop after I read my first line too. Maybe I'll put a breakpoint right here. Now debug it. I'm come to that line. I can hover over my I, has value of 1. I'm going to step over. All right, where's my step over? Right here. Step over. Now let's see what line I read. Look at that. It shows me I read that value from the file. And now I can see that it has the space and then 3 T's. Step over. Step over. It read both things. And now let's see what is in a result. I can see what it's holding right now. Because I declared it an array at the start, notice what's in there in the rest of the array. It's filled with nulls. That's why I was doing this thing up here. While it's not equal to null as I'm processing it, because I saw when I was debugging that when I make this array, until I put something in there, it has nulls set in there. And that's processing that input file. So here's where the tricks were, right here. Reading the line and then getting that first word using the convenient split function and the substring function. And the lovely thing about Eclipse is I can just do the name of my variable, S line, dot, and I see all the possibilities available for me in the autocomplete. Oh, got to spell it right. capital N. You know, I can explore my code with the autocomplete. What's available for me with strings? Now, the nice thing about those onlines, it forces you to remember this stuff. But as you're learning code, that autocomplete is so helpful. Otherwise, you're constantly digging through reference manuals, spending most of the time doing that. Okay, I hope that was helpful for you. We'll stop there. This is recorded, and you can go back and have all the code. If you want to do it exactly like I do, you can. But compare this to how you did it. If yours works, don't worry about doing it the way I did it. But these are two nice functions, the split and substring, that I've just gotten used to using as I've done a lot of string processing.